For today, let's look at understanding randomness. For each of the following scenarios, decide if the outcome was random. Flip a coin to decide who takes out the trash. Is who it takes out the trash random? So I'm flipping a coin. Is that considered random? Yes. Number 2, a friend asks you to quickly name a professional sports team. Is the sports team you named random?
No.
Yeah, they didn't say what type of team.
Just name a sports team. Saints. Now, why did you pick the Saints? Are you a Saints fan?
Sure.
So would you say there's some kind of bias based on that?
Oh, yeah.
You see? So what comes out of your head could be a bias. Like the Rockets. Well, I'm biased because we're in Houston, right? When I was in Miami, I was a Heat fan. Bias. I was in Miami. Second one, names are selected out of a hat to decide roommates. Is your roommate for the year random? Yeah, kind of like the lottery, right? Randomly selected. Now, how could it not be random?
You request
If you request somebody.
If you request somebody, how selecting names out of a hat could not be random? How could you rig the system?
If they, I don't know, if they're like different colors.
No,
Put more?
decide whose name.
Yeah, like maybe you already had the slip of paper in your hand.
Yeah.
Or put more, that's a good one. Put more people's name in the hat. Like if everybody likes John, put John's name in there 6 times and everybody wants. Something like that. Let's look at this one. Many states run lotteries, giving away millions of dollars if you match a certain set of winning numbers. How are those numbers determined? Do you think this method guarantees randomness? So first think, how does the lottery work? Does anybody know? Here's how lotto numbers are picked. Pretty similar to drawing names out of a hat. Do you say this selection is random?
Yeah.
Yeah. What? No? The American College of... Why did they put these big words in here for math teachers? Obstetricians and gynecologists say that out of every 100 babies born in the U.S., 3 have some kind of birth defect. How would you assign random numbers to conduct a simulation based on this statistics? So we want to use a random number generator. I have how many total? 100. How many have a defect? 3. So why do I say randomly select between 1 and 3? If I get a number 1, 2, or 3, that's considered defective. And between what numbers will give me healthy babies? 4 to 100. Very good. 4 to 100. If I get those numbers, I am, let's say, healthy. Yes. So this is how you would set up for your random number generator. And of course, let's go back to the calculator and show you how to do a random number, or using the calculator as a random number generator. You're going to click on, where is it at? Math, probability, random int, which is short for integer, my lower 1, my upper 100, my n total of 10 babies, and first baby, was it healthy? Second baby, healthy, 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 healthy. Actually, what that n was how many times you want to run this test. So if I just put 1, so math, probability, random int. If I just change this to 1, that's just going to be 1 trial. Did I have a healthy baby? Yes. 48. As long as I don't have 1, 2, or 3, the baby is considered healthy. So let's explain why each of the following simulations fails to model the real situation properly. We're going to use a random integer from 0 to 9 to represent the number of heads when 9 coins are tossed. Why is this a bad simulation? Why is this a bad simulation? Not letting you off the hook. Think about it. Think about how heads and tails is randomly selected and how many options you have.
Is it because heads and tails is 50-50, but that's an odd number?
Very close. So my random number generates 0 to 9, but we're 50-50. It's either going to be a 0 or a 1, right? So yeah, that's not going to work. If I get an 8, how's that going to tell me if it's heads or tails? That doesn't make much sense if it's just 1 or 0. So yes, that's why this fails. Oh. B, a basketball player takes a foul shot. Look at a random digit, using an odd digit to represent a miss. Why does this one fail the simulation test? Basketball player takes a foul shot.
It's like 5% is 50%.
Yes, this is assuming that he's shooting 50-50, right? Odd or even. And we know that not everybody's going to be 50-50. Usually it's based on skills. Some people are 80-20, 90-10. So yeah, this is not going to work because it assumes that they're just going to be a 50-50. Use a random number from 0 through 13 to represent the denominations of the cards in a 5-card poker hand. Why does this one fail? Think I have all my cards. I pick an ace, right? That makes sense that I have a 1 in 13 chance of picking an ace. It's now out. Now I pick again. Does that ace still have a 1 in 13 chance? No, because you already took one away. So now it has least likely a chance to pick an ace because there's only 3 in there, right? So that's why this fails. It assumes that all cards are even. Well, once you take one away, they're no longer even, are they? So it works on the first trial, but will fail on all the other trials. What if you take all 3 aces out and you have 1 left? Well, that's not fair because you have 4 of the others and just 1 ace. Okay, let's start building simulations. A large manufacturer of batteries knows that historically 3% of its batteries comes off the production line defective and cannot be repaired. 7% are defective but can be repaired, so a total of 10% are bad. And 90% come off working. So 10% are bad, 90% are working. Conduct a simulation to estimate how many batteries the company needs to pull 10 working batteries off the production line. So describe how you will use a random number table to conduct this simulation. So we're using a random number generator. How should we set that up to represent 10% are bad, 90% are good?
Is it 1 to 10 or 1 to 100?
Okay, you can do that. So she's saying 1 in 10 represents defective. And then 11 through 100 is working. Yeah. That'll work, right? So your range is between 1 and 10. Oh, sorry, your range will be between 1 and 100. Numbers 1 through 10 will tell you defective. Any other numbers will say it's working. You can shorten this out by dividing by 10 and say 0 and 1 equals defective. And 2 and through 10 equals working. A lot smaller range, might be a little bit easier to work with. But still, same thing. 10% are defective, 90% are working. 10% are defective, 90% are working. So up here, this used 0. Did I use 0 or 1 and 2? I used 0. So mine actually used 11, so I'm wrong here. I would use 1 as defective, 2 to 10. Okay. This one's going from 0 to 9. 0 is going to be used as defective. 1 through 9 is working. Total is a 10. That's 10%. Here are our trials. So, based on trial, my first, was it working? Yeah, 1 is considered working. 0, was it working? No. So X. So I have 1 that's worked. 2, is it working? Yes. So I'm looking for how many? I need 10 to be working. 4, working? There's 3. 2. 5. 0.
No.
No. So I have 1, 2, 3, 4, 5, 6, 9, 2, 1, 8. So here we go. I got all 10. I now have 10 that are working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It took how many tries? 12 tries, right? To get 10 that are working. Trial 2, 8. Working? 1. 1. 8. 3. 4. 8. 5. 5. 4. Hey, the machine was working good that day. So it only took 10 trials to get 10 working batteries. Trial 3, 0. No? 6. 7. 6. 5. 6. 7. 0. 4. 1. 2. What? 1, 2, 3, 4, 5, 6, 7, 8, 9. 0. 4. Now we have 10. And that took 13 tries to get to our 10 working batteries. State our conclusions. So you can conclude that at least how many batteries off the line will give us 10 working batteries? At least how many, based on our trials? No? At least how many batteries will come off the line to give us 10 working batteries? Not 10. If you say 10, we're assuming that it's going to work every time with all batteries, right? 12. I hope 12, but it's actually 13. It's fell in 13 times here. If it was already to like 17, then we would need at least 17, because that's what this came out to be. That's what we're going to be using these trials for, is saying, okay, what was the longest one that took me to there? That's the least I need to assume that may happen. Could be 4, I mean, if we could do more trials, it could be 17, could be 20, could have bad luck. Machines get old and, wear out more. But for right now, it looks like at least 13. I need to assume 13 batteries coming off the line. Let's look at this one. As a 4-H project, Billy is raising chickens. He feeds and waters them every day and collects the eggs every other day. Sell them to people in the neighborhood. He has found that each hen's nest will contain 0 to 2 eggs. Based on past experience, he estimates that there will be no eggs in 10% of the nest, 1 egg in 30% of the nest, and 2 eggs in the other 60%. Conduct a simulation to estimate how many nests Billy will have to visit to collect a dozen eggs. So describe, how will you use a random number table to conduct this simulation? So if we're using numbers 0 to 9, tell me, how does it split up between 0 eggs, 1 egg, and 2 eggs? Okay. 0, just 0. Okay. That's 10%, so 0 equals no eggs. So if we get a 0, we're going to say no eggs. If we get a what will equal 1 egg, and what will equal 2 eggs. Oops, why did I do that? You got to start at 0? Okay. Christian? If 0 is no eggs, what numbers will we use for 1 egg? Notice 1 egg is 30% of the nest.
Could be 1, 2, and 3, right?
Very good. 1, 2, and 3 will represent 1 egg, and therefore 2 eggs is 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6 out of our 10 is 60%. So 0 equals no eggs, 1, 2, and 3 is 1 egg, 4 through 9, we get those numbers, and our random number generator will equal 2 eggs. Yep, that's our 10%, 30%, and 60. So this experiment uses the same thing. Trial 1. So our goal here was to do what? A dozen eggs. So trial 1 had 5 eggs. How many, trial 1's number was 5. How many eggs came out of there? 2. Trials, the next one was 7. How many eggs? 2. 5? 2. 1, 2 gives me 1 egg. 8? 2. 7? 8? See, do we have a dozen yet? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, 12. Right? Oh, that's 11. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, never mind. So it took how many tries? 1, 2, 3, 4. How many hens? 1, 2, 3, 4, 5, 6, 7. Trial 2. 9 represents how many eggs? 0, 0, 6, 7, 6, 3, 1, 9. How many do we have so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one took 1, 2, 3, 4, 5, 6, 7, 8. 8 visits. Trial 3. 3 represents 1. 1 represents 5, 7, 4, 2, 8, 0, 4. Let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right here. So it took us 1, 2, 3, 4, 5, 6, 7, 8, 9 visits. At least how many visits does it take Billy to get his dozen of eggs? 9. At least 9. Could be more. We just did 3 trials, but for our simulation here, 9 visits.